Good evening, everyone. My name is Giriraj Bagdi. I work at Intuit in data platform team. Welcome to Intuit for a Democratize Data meetup. Today is a very exciting journey. We're going to talk about data observability in the big data platform. But before I do a deep dive and invite the speakers, I have a basic question. How many of you have ever traveled in a plane? All of you, right? Are you willing to fly in a plane which has lack of monitoring in any shape or form? I'm pretty sure none of you. Good luck if you want to. Right. So let me change the analogy. Imagine we are managing a big data platform without any monitoring or observability. What will happen? Bizarre, right? So today's topic is about observability in data platform. So we have two big sessions. First session is covered by Intuit, which is lightning talk of 15 minutes each of 4 of them. And second is by Unrival. So without further delay, I'd like to invite our first set of speakers, Preeti, Gayatri, and Tulsi Prabhu for a first lightning round.
Good evening, everyone. My name is Gayatri Dhanasekaran, and I'm part of the Quick Data Fabric team. Today, my team and I are super excited to present the first lightning talk of the evening, which is about database schema changes and its integration with Lineage tool, which is a tool developed at Intuit, and the unique solution that we have put together for identifying and resolving the most common issues that you would encounter in the data analytics infrastructure. Does this slide strike a chord with any one of you? I'm sure everybody is interacted with databases. Yes? Great. So, schema changes. What is the connection between schema changes that are made on source systems and its impact on data stream, downstream data streams, downstreams data pipeline, downstream systems? Schema changes are complex, they are intrusive, and they have a profound impact on the application availability and also on the downstream systems. This is because there are thousands and thousands of source databases in our production tier, on a production scale databases. And you have thousands of pipelines that are interacting with all of these source databases. Consider a situation, or it's even possible that some of you have been part of this incident or a situation where a schema change in a source database system has actually broken pipelines in downstream systems. It has caused an impact on the reporting SLAs. It's caused data loss, data corruption, data sync issues, which has taken days, weeks, or even months to resolve, depending on the complexity of the problem. Most of the time, most organizations run into this problem because of 3 main reasons. There could be other reasons, but we have narrowed down to 3 main important reasons at Intuit. 1, there is a lack of timely alert on changes that are made on the source database systems, especially schema changes, especially the changes that alter the structure of the database. Second, data analysts and engineers, who are the guardians of the data analytics infrastructure, they don't have visibility into the source, into the changes that are being made in the source system. Third, there is an absence of a process and or a tool that can be used to proactively identify some of these changes or impact even before they could be rolled out in the source database systems. Do you think it will be super exciting if we did have a solution to identify and proactively resolve all of these incidents and issues?
Yes, Gayatri. I think we are going to show exactly the same solution today. Good evening, everybody. I am Preeti Singh. I am a staff database engineer at Intuit. For the challenge that Gayatri just mentioned, we came up with a solution that gives near real-time automated alerting of critical schema changes that can potentially have a very negative impact on the downstream system. For our solution, we used a couple of AWS services. We used Splunk and Intuit's open source framework called Quick Data Superglue. The good thing about this solution is it's very generic. We can use it with any database technology. We can use it with Microsoft SQL Server. We can use it with Oracle, Postgres, even with any NoSQL database like Cassandra. In today's demo, we are going to use AWS Aurora MySQL to show end-to-end working of the solution. I'll let Susie to proceed with the demo.
Thanks, Preeti. Hello, everyone. Thank you for joining. So I'm going to dive right into the demo. As Preeti mentioned, I'm going to show you the demo today, especially on Aurora MySQL database. So the way I'm going to do it is, first I'm going to fire a SQL query here, especially the DDL query, and I'm going to take you to the end result as to what is expected, and then we can walk through step by step how this was implemented. So to start with, I'm just going to create a table here, and I'll do a simple alter to that table. And what I expect to see in my end result is something where through Splunk log or through AWS Cloud Log, we are allowed to see the changes that have happened. So let's go right into that. So as you can see from the timestamp, the changes that I made on the table are captured here. So let me just refresh that. So this is a create table. So there are two logs here. So let me click on this one. This is the one that we are interested in. As you can see, the SQL statement here is captured. Also, it is telling me what's the name of the table. The most important part here is the Superglue URL. This is Intuit's homegrown open source system application, where we are making a call with the table name that we just changed. And what we are going to get back is a very useful information. Let me expand it and show you. It's giving us a list of reports that are impacted. So how this is useful is because even before we make the change, we can see the impact downstream into our data lake as to which reports are going to get impacted because of the simple change that we are making. So I took you to the end of the slide here basically to show that this is the result that we are expecting. Now let me show you the setup part. So it all starts with our database. So the setup starts with two things, especially on the Aurora MySQL side. The first one is on the cluster itself, we need to turn on the auditing part. So, and the way to do that is you can set it up at the cluster level or at a particular instance level. At the cluster level, we need to turn on the audit log here to tell the engine that we want to audit these queries that are coming in. And the second part is the configuration for the parameter group. If I look at audit, there are 5 different parameters here which are of interest to us. We need to turn on query DCL, DDL, and DML. And for this particular demo, the DDL is the one that did the magic. And we can exclude and include the users, whose DDL activities that we want to monitor. Usually, we tend to exclude the application user, and we want to keep track of all the users that are usually the DBAs and the application developers and things like that. And the last two, one is to say that we want to log all these activities into the log, and the second one is to say that we want to upload these logs to AWS logs. So that's the first part. The next part is the Lambda function. So we have a Lambda function which is taking the log to the next level. Basically, it is reading off of the log that you just saw. And we have a Python function, which is reading the log and making the superglue call that I just showed you earlier. So let's go to the Lambda log. So in the CloudWatch. And as you can see here, this is what I was showing you earlier. So the second one is the one which read the log from the CloudWatch, which was the Aurora MySQL log, and it extracted the information that we need. It did the superglue call, and finally, it wrote the information to this particular log. That final part of this puzzle is Splunk, of course. So this is the one that pretty much goes and reads the information from the Lambda log and sends out an email alert. So this is the end-to-end from beginning till the end. And these alerts can be set up, depending on the frequency. Since we have 15 minutes, so it is probably still in the pipeline, but I wanted to show you, it shows that one event is matched. I think it is pulling the data, but it is there. So in 15 minutes, we are going to get an email alert for that. So let me jump right back into the presentation here. Mm-hmm.
No impact? It's, yeah.
Yeah. So if you created a brand new table, we don't have the metadata for that, right? So it's not going to have any impact. So if you added a new column, no, right? But if you dropped a column or if you dropped a table, it is going to have an impact, even if it has an impact, right?
It's not handled properly in the downstream.
So let me draw your attention to this architecture and information flow. This is pretty much summarizes what we just talked about. The user making the change goes into the MySQL database, and the CloudWatch captures the logs, and the Lambda function reads the information from there. It makes a call to the Superglue API, gets the data back, writes into the CloudWatch log, Splunk picks it up, and sends out the email. I talked about these two setups that we have to do from the MySQL DB side. And this is pretty much to show that the Lambda function here is reading the data of the audit. And the Lambda function here. I wanted to show you also, you can do this filter pattern here in the bottom of the screen. If you can see it, it's really hard to see, but this is where the trigger is triggered from. So you can add the commands that you want to capture, the Lambda function to capture. This is a sample of the alert that we just received, which I shared. Again, in the bottom of the screen here, sorry, it's a little hard to see. This is where the Splunk is subscribing to the Lambda log. And this is managed by our Intuit, one Intuit logging. So pretty much they manage our Splunk alerting for us. I showed the Splunk lineage information. And this is a Splunk alert that we would get, which I could not show you, unfortunately, because of the timing. This is a sample of the DDL alert email that you would get. This is a UI for the Superglue, but we did an API call to get the data. But this is how you would see the data if you were to do this in the UI. And this is a pictorial representation of how the UI would look like. And I'm going to turn it over to Gayatri.
Thanks, Tulsi. That was an awesome demo. So I would like, since now that you guys have seen the demo, I would like to draw your attention back to the unique benefits that this has offered us. One, it has dramatically improved our operational cost. Second, it has helped us identify any negative reporting SLAs on downstream systems. The third big important piece that it has done is it has actually unlocked the power for our data analysts and data engineers, because now they have the information at their fingertips to subscribe for this information at will. They're not dependent on the DB engineering team. They're not dependent on database engineers. They can subscribe for any alerting that is of interest for them across the Intuit ecosystem. So they're not dependent on a particular team to hand over that information. So this has truly moved the needle for us and has helped us identify and resolve a lot of issues. So thank you so much. Yes, you had a question? Mm-hmm. Yes. Uh-huh. Yes. It completely depends on the configuration. You can customize because in Splunk, when you're creating a report, you can customize to do whatever you want to do. Specifically, if you had looked at the one of the slides that Tulsi had specifically showed, we used 3 different components for it. We are tracking the DCL changes, which is data control language changes, which is potentially if somebody dropped a database user account in production, it would be catastrophic, right? And we can capture that. We are also capturing DDL changes. In some instances, the auditors even, we are heavily compliant on PII and SOX compliant data. We can even track BML changes for particular users. So that is completely on the Aurora MySQL portion of it and how we configure the database configuration. But when it comes to Splunk and CloudWatch, it's completely within the capacity of the engineers. It's up to us on how we want to configure. But once it is also in Splunk, it allows the end user to subscribe to whatever model that works for them. So we are not holding off that information at just the layer of CloudWatch. Once it's in Splunk, it's available for everyone. Yes.
Thank you. We'll go to the next session. I think after the whole round, we'll do more Q&A. Thank you, Gayatri, Tulsi, and Preeti. So moving on, the last lightning talk is about EMR monitoring. And we have Khilawar Verma on the podium to talk about in next 12 to 15 minutes. Welcome, Khilawar.
Good evening, everyone. My name is Khilawar Verma, and I am part of Quick Data Platform team. And this is my team sitting here. I'm really proud of you guys. Today, we are going to talk about the EMR observability in this session. And I just wanted to show you this picture because I think everybody can relate what this means. Because everybody in the data field actually somehow they face these kind of problems. And also, of course, I will walk you through what does it mean. Let me give you a scenario where you have 1500 plus data pipelines running across 40 or 50 plus EMR clusters, which they are spread into multiple AWS accounts, right? And they are increasing day by day. And how we are going to support this vast and volatile infrastructure, right? Now, let me give you another scenario as well. You have 300 plus analysts, data scientists, data engineers, and data leaders who are constantly looking for cluster health, reports, historical data, job execution stats, cost detail, etc. How are they going to find this kind of detail and where? What is the place where they can go and look for those kind of things? And who is going to support this kind of crazy number of asks? So, sooner or later, you will see that, these customers will actually start yelling at a frustrated data SRE. And of course, I was one of them, but not anymore, luckily, because now we have something to show you. That's why we are here. Now, if you don't solve this kind of problem, if you don't democratize your observability as a service, these problems will become a bottleneck for data SREs. And data SREs ultimately will become a bottleneck for your business outcomes and SLAs, right? Now, when we were developing these solutions, we actually concentrated on 4 important customer pain points, right? And we took them as our principle for designing this solution. And you will see in the demo how we actually converted these pain points into smiley faces, because that's what we do. Now, the first problem, and we, of course, we divided these problems in a sorting order, right? So the first is the main pain point, where, of course, you can find these kind of metrics which we are going to show here by doing a manual steps. And, of course, they are very cumbersome, but ultimately you will reach there, right? And trust me, this is one of the metrics which we are gathering from EMR Resource Manager, okay, by just going through 8 steps, okay? And now think a scenario where you have multiple clusters running across multiple accounts. These steps will actually multifold very quickly, right? And if you don't have automated solution, good luck with this manual process. Of course, we are not going to do that. So what we have done, we have designed a solution which is just one button click. Whatever things you do manually, you will be able to do the same thing by just one button click. Of course, you want to see how we are doing it. Now, let me just take you to the demo. Just come here, one button click, and you see the data. Of course, you'll see what does it mean. I will walk you through. But what I'm trying to tell you that, whatever you will get the data from this manual step, this is one of the metrics I'm talking about. Of course, I don't know whether you can figure it out. What is this? Maybe mostly people, because they know what is resource manager and all. But, you still have many other systems which you need to connect to find the data, like cost and, timeline server and so on and so forth. And this is the data I was talking about. So good thing that, we solved the one problem. Now let's move on to the second pain point. The second pain point is the user persona. What does the user persona mean? Every organization may have different kind of users, and they have their set of expectations, what kind of data they are looking for, what kind of format they want, so on and so forth, right? Even in our data platform, we have 4 main important types of users, like data analysts, data scientists, data engineers, and of course, data leaders. Now let me walk you through their expectations and how we are meeting their expectations into just one screen, right? Data analyst, of course, they are easy to solve because their main concentration is to, find out how my cluster is performing, whether they are good or not, it's healthy, unhealthy, those kind of things, right? So when they come here, they can just see here, it's, of course, we did some kind of color coding so that they can just easily see, okay, my cluster is green, which is healthy. And with this, when I talk about the cluster, it's the EMR cluster we are talking about. And yellow means running and so on and so forth. Of course, we are also showing some kind of number, which is actually representing a live data, which means live jobs are running into the production system here. So in this particular cluster, 5 jobs are actually triggered from the production schedulers. Now, of course, some people say it's a cluttered view, because if you have multiple accounts, of course, you will see many clusters showing up here. Some people say, I don't want to see this kind of clutter data. Of course, we have shown some kind of filter, and marketing person comes, they can just filter it, and only they can see their particular data, right? Now, so now we are good that, we solved one customer persona. Let's move on to the next one. The next one, data leaders. Of course, they are interested into these kind of matrices as a Uber picture, but they are also actually looking for one important matrix. Any guesses? Wow, everybody knows. Okay, sorry. So yes, cost, and of course, one of my data leader who's smiling at me, he is really, really fond of cost. And you will see actually in next 20 minutes or 30 minutes, so when he come to podium, that why he's so much interested into cost. And he really has, hawk eyes when it comes to the cost. I wanted to say eagle, but hawk is also okay. Now, so how we are going to solve that persona, right? Of course, again, we are actually talking about button clicks. So now let me just click one button, right? So let me just refresh this guy. Let me click this button, and this is your cost. And of course, you'll see the smaller numbers because this is the monthly cost, and we are on the 3rd day of the month. So you'll see the smaller number, but they are really going to shoot up very quickly. So now my data leaders are happy. Let's move on to the third persona. Third persona is really, really important because we are talking about the data engineers, the large chunk of the user persona, and the SREs, because they are the one who's actually going to do the debugging for us and solving the problems, complex problems, right? How we are solving their persona into the single screen. Of course, again, one button click, come here, and you will, so what I'm trying to navigate is actually going from smaller simplified view to now more detailed complex view, so that they can, because they need more data, more metrics to actually find out what's going on into their system, right? For the debugging purposes. So here what we have done is, we are showing into 4 or 5 different parts so that it's easy for, understanding what's going on. Now, first is a cluster detail. We are also showing business owner. People will ask why we are showing it, because of course the business owner for this particular cluster is important, because somebody is actually running into an issue and they want to kind of get approval immediately. They don't need to juggle here and there. Just come here. Oh, he's the business owner. Let me reach out and get some kind of approval if I have to run some command or change some systems, right? And of course, we are showing some other bunch of data, what kind of things are running and what is the hardware capacity and so on and so forth. Now, we are also actually bringing some, historical data, and people will say why it is needed. Yeah, one of the solution one of the answer, sometimes when people and one like me, when I start looking for the issues, when I start debugging, I always think, that, if this issue is a recurring issue or it actually happened just now. How would I know that? Only unless I have a historical trend or historical data, I would not be able to see this, right? I will not be able to know whether it's a new issue or recurring issue. And then that can actually drive me to solve the problem or debug the issue or narrow down the problem, right? Now, that's why we have actually, hourly, daily, weekly, and historical trend as well. Let me also talk you through. So now, what we are trying to show it here, we are actually divided the historical data into multiple parts, like, some are related to jobs, some are related to system health, right, and cost and other things. So the job stats shows here, how many jobs actually completed or ran or currently running in that 24-hour, or like average job failed, successful, and all those stuff, so that you will know, how my cluster performed in last 24 hours. And similar, some people are not interested into graphical representation. They can also see a tabular format here. Now, one of another thing people always ask that, okay, my job is running, something is wrong in particular job, and I want to know only about that job. I found out that, these are the job stats, these are the system stats, but I also want to know what's going on in that particular one job. So we have also given a more depth view where you can come, okay, now see for this particular cluster, 5 jobs are currently running. You can click it here and you can see 5, right, which means they just now changed to 3, right? Now you'll see it here that they are actually 10% completed till now, and they are utilizing 111%, and this much time they have elapsed till now. So we can narrow down one more level where you can actually find some insights so that you can start debugging more. Some people say, I don't want to come to the system sometimes because I am on leave or something. That's okay. We are covering those users as well. What we are doing, we have actually enabled monitoring, EMR alerting, right? So we are also sending an email so that they can actually come and see what's going on in the system, like a system health. And also we have a Slack integration, so we are sending the similar kind of data. So we are covered. Now people are happy because they can see what they are looking for. So we solved the second problem. Now let's move to the third one. Third one is, okay, you are able to generate a lot of metrics, but is it good enough? Are you also finding some kinds of business insights, which are very important, like, whether this metrics is meeting a business SLA. It is solving my customer problem. Is it solving the job efficiency issues? And is this helping me to cut down the cost, right? So what we have done, we have developed our own algorithm, right, which we call it recommendation engine. And there what we do, we are actually finding a job scheduling and resource utilization and merging these stats together, and also giving some kind of recommendation which helps in job efficiency as well as save the cost. Let me show you how. We call it expert advice. So here, if you see, I don't know whether you can read it or not, but let me read it for you. We are actually telling users that, if you can just switch your job scheduling window from highly utilized time to some less utilized time for the cluster, so that cluster will be balanced, you will get better efficiency, and ultimately you will use the less hardware to save the cost, right? So that is the third part. So we are good. We are able to, help them generate the business metrics. Now we are able to solve 3 problems. The fourth one, which is also sometimes very important, and it is more closer to me because other 3 you see, somehow they are actually related to business. They are business-driven problems, but this one is a technology-driven problem. The head of our data platform, Sandeep, used to say, build the right product, and give it at in the customer hands so that you can actually start gathering all the feedbacks so that you can start building the product right? So what we started doing, we firstly, first three things, if you see, we actually solved the customer problems and we given this solution to their hand. We started gathering the feedback and we are started building the product right by, following all the industry best practices, like, all 9 yards for your logging, access control, SSO implementation. You are not doing any rework. You are not generating any tech debts and those kind of things, right? Is it good enough? Of course not. So what we have done, we have actually built this solution as a cookie cutter design pattern for EMR for the first phase, right? What we are trying to say that, this cookie cutter pattern can be easily applied if you wanna bring more big data infrastructures into this system. Like, you have a Redshift, which is picking up very quickly. You have Athena, which we actually launched to the analyst community a few months ago. You have very large Vertica clusters, right? How can you implement this one? And because of this is a cookie cutter design, it's very easy to inbuild and bring the solution here. Are we stopping there? Of course not. Because we have done so much good things, we wanted to share the love, right? And we are really motivated that we are going to give this tool to the community by open sourcing it in the near future. So now let me just summarize it. We are solving the complex problems, removing a lot of manual steps into one common button click. We are generating a lot of insights, which are ultimately solving the business customer insights and SL meeting the SLAs. And of course, we are kind of motivated to share the love to the community. Thank you, guys. I'll open for the Q&A. I think I have only one minute.
Only one question, please.
So is there any isolation? Like, I think the demo said you can be from marketing team or
Sure.
team. If I'm from marketing team, if I open, can I see everybody's cost or only my cost?
Yeah, so that is where the access control comes into picture, right? If you have been given an access only to the marketing, you'll be able to see only marketing unless you are admin or super admin, which is given by us. Yes, that's where the access control comes into picture.
Thank you, Kilauer.
Yeah.
Moving on. Was it exciting, guys? All right, more fun coming. The next speaker is Tak, and he's going to cover the demo for us now. While he's setting up, yes.
Okay, thank you, Gire. Hi, my name is Tak Saito. I'm a senior data engineer from the data platform team at the Intuit. And tonight I'm going to talk about the anomaly detection. So the problem statement is, why do we need anomaly detection? We need anomaly detection because we have the bad quality data. So here I have the article saying that in 2016, IBM estimated that bad data cost the US $3.1 trillion. So that's a quite high number. Business leaders rely on the data that we ingest. Let's say that, data is the, bad quality, that, they don't have any trust in the data, so that they cannot make any, critical business decision in the timely manner. So possibly that they can be losing the potential business. And another example is that, let's say, somebody, I come to some web services, let's say the social media, right? And I happen to be recently got divorced. But this social media pop up some ad, trying to sell me some cruising package, designed for the honeymoon, right? So I would never come back to this web service because of that bad customer experience. So we need to have the good quality data. In order to have the good quality data, you need to have the anomaly detection. Not so long ago, Intuit was not the exception. We didn't have the anomaly detection. So this is a line chart that's showing one of the critical KPI, which is the gross number of the new subscription for the QuickBook Online. So black line is the actual data. So that line is basically pointing downward. there's a dip, there's an anomaly. So this bad data is already consumed by the business report. And then analysts, come in to look at this data, and before they are presenting this data to our business leader, they find anomaly, and then we typically get pinged by them through the Slack saying, hey, there's an anomaly, find this in this number today, can you check, if this is really anomaly or not, right? I think there are three bad things happen here. One is the bad quality data was already consumed by the business report. And second, the anomaly was found by our consumers, meaning that analysts. It wasn't detected by the data engineer. Third, if this kind of stuff happening over and over again, our consumers start losing the confidence in our data. So that's the last thing you want to have as the data engineer or the service provider. So now that we have the anomaly detection placed in our pipelines. One of them is the metric anomaly detection. So before the data was consumed by the business report, we have this big table, daily snapshot table, which stores different kind of KPI. So one of them is the one I just had an example on, gross new subscribers. And other is the signups, net subscriber growth, net attritions, and total number of subscribers. And this daily snapshot table is the multi-dimensional. So one column has the different number of the products, such as the QuickBook Online. And second column is the country, such as US, UK, Canada, and so on. So these are the countries in which the Intuit operate business. And third dimension is the marketing channel. So this is a channel that we use to win the customer. So when you combine these, different dimensions, and each dimension has the different values. So this combination turned to be hundreds of them. And we turn into those combinations into the metric query. And we run those queries against this big, snapshot tables after we finish the pipelines. So each pipeline returns the time series dataset, which we feed that dataset into the 11 machine learning algorithm. So, if the each machine learning algorithm basically return 1 or 0, 1 meaning there's an anomaly, and 0 meaning there's no anomaly. And in our case, if the 7 out of the 11 algorithm, found anomaly, we basically send an email alert to data engineer for them to look into the issue further. So this slide shows the example of the such an email alert. So in this particular day, we had the 4 anomalies. And then if you look at the number on the right-hand side, under the algorithm, you see the value 9. So that means we have the 9 out of the 11 algorithm find the anomaly. So that's a pretty strong indicator that this is the actual anomaly. And next, another indicator we have is the median value versus actual value. So it's basically measuring the deviation from the weekday mean. So that's another indicator that you can use to sense whether this is the it's worth looking to this anomaly further or not. So if the data engineer decides so, he has a choice to click this view alert button, which take her to this wavefront dashboard. So when we run the metric queries against the big daily snapshot tables, it returns the time series dataset, and we persist that dataset into the S3 bucket, which will eventually consumed by the wavefront to display this historical trend of each metric. So data engineer can come into this dashboard, and he can compare the actual value versus the historical trend to make sure that this is the actual anomaly or not. And sometimes, you find the false positive anomaly. So example is that, toward the end of the month, we see the spike in the number of the cancellation of the service because people don't want to get charged before, people typically, cancel the service before they get charged. So that become the false positive. In such a case, we don't want to get this kind of false positive like every month. So somehow we have to train our machine learning algorithm, better. So we have a mechanism to do so. So our data engineer be able to come to here and be able to give a feedback on that, anomaly. So there's a question say, is this value actually anomalous? And when you answer correctly, our machine learning algorithm would be, take that into account and then, provide a better algorithm in the next time you run it. So the one that I just talked about is the metric anomaly detection, which typically happen at the end of the pipeline, right? But anomaly could be happen at the beginning of the pipeline too. And when it's happening at the beginning of the pipeline, I would like to catch at the early stage, right? So we have the another detection called the raw data anomaly. So basically the data is flowing from the source table to data lake. In the data lake, we have the raw data tables, right? So we do three kind of checkings. One is we are checking the number of the row counts. And second, we are checking if the value is null. And we raise the flag when, there's a null and when it's not supposed to be null. And third one is the cardinality of the column. So if there's any significant change in those three checks, we basically shoot out the email, just like, how metric anomaly detection does. So as the future work, what we'd like to do is when we find this kind of anomaly, we would like to basically stop the pipeline immediately so that, bad quality data doesn't flow into downstreams, right? So we already have the primitive circuit breaker. So in the case the row count of the raw data table is 0, we basically stop the pipeline. We fail the pipeline, and then immediately data engineers start looking into the issue. But we would like to extend that circuit breaker feature into other checks as well when the column value is 0 or the cardinality of the column has significantly changed. So that's something we would like to do in the future. So in the summary, what has changed since we have we put the anomaly detection is that issue is caught at the early stage now. Issue used to be caught by our analyst, and it was already consumed by the business report, and our business leader couldn't, make a decision in the timely manner. So that was really the reactive approach for us before we start digging the issue. Now that we have the anomaly detection in place in the pipeline, we can take the more proactive approach. Even though bad data might be flowed down into business report, we can probably alert them. We can tell the business leader to hold on to make any business decision until we resolve the issue. And second one is since we are taking the proactive approach, detection and recovery time has a lot shorter than it used to be. And then we have been meeting the SLAs in consistent manner. As a result of that, operation cost has significantly reduced. Used to be that our data engineer got pinned by the analyst. We drop our daily task and then we storm into the warden. And then lucky day we might resolve it within the hour. But if it's not lucky, it could drag into 3 days, and then you basically miss your daily task, right? And as a result of all this, now that we are gaining back the trust from our business leaders as well as the analysts in the data that we ingest. That's all I have, and now I'm going to open up to questions. So those 11 algorithms are actually developed by the data scientists. So, it has the many different type of the algorithm. We are not the one that we are picking. So those are the typical 11 algorithms has been used across the company. And then, based on that, we did many experimental, and then we are picking the 7 out of the 11. When the 7 algorithm raise the flag, that is typically it's the actual anomaly. Yes. So right now, the way we do it is when we run the metric query, we are getting the time series data since the beginning of 2018. So every time we run it, we actually train it. So that training is pretty fast because you are only getting the data from the beginning of 2018. So I know that that is not really the efficient way. So one of the changes that we would like to do is not to run that, train the machine learning on fly. We would like to run train it on the beforehand. So that's something we are changing.
Thank you.
Thank you.
All right, guys, I'm back. So this part of the session, I'll be covering a topic which is very close to my heart, costing. So looking at a slide, where is the money being spent? This will be a bit interactive session, so pay attention. How many of you are in the cloud, maybe any kind of cloud? Can you raise hands? All right, pretty much most of them. How many of you are managing and looking at a cost on your accounts? Some of them, very few of them. So let me give you a scenario. Imagine you are the owner of the account and you have the permission or you have authorized to give all your team access, because of course you can't do everything on your own, and spin off resources. Wild west, right? It's nice to go on a cloud like AWS, but you have unlimited resources. You can really play around, right? Now let's multiply it. In this close to 80 people in an organization, I have 80 accounts. 80 accounts, multiply the number of developers, what will happen, right? You will very soon see the graph which is on the right-hand side. The blue indicates what was the budgeted allocated for that particular month for all the accounts. And the middle of a month, you see, I'm trending red. I've already blown 2/3 of my money. What will happen? You have no choices, man. You have to run production workloads. You have to come with some scenarios. So next slide, please. Similarly, we were in this kind of situation months back. We learned the hard way, guys. So we had a challenge whereby we are hosting multiple accounts. We were overshooting our budgets. And guess what? We were doing war rooms after war rooms, getting people together. What really has happened? We found out our tagging is missing. We were not tagging resources. We found out we have underutilized resources. And we found out we're not looking at a cost, and it was trending up and up and up. Guess what? Not anymore. We learned the hard way, and we systematically designed a system, one-stop shop from two, to come here with a cost buddy whereby we are happy, our engineers are happy, our leaders are happy, no more of war rooms, one-stop shop to come and look at our cost trending, what we're happening. In fact, we went miles up. We started anomaly detection, alerting, monitoring, tagging. We put some rules around whereby we have better utilization of resources so that there's no surprise to any of us. And as a developer, I can use the resources what I want rather than chasing around things. Now, how have I done it? let me show you next slide. And these are the key takeaways: single dashboard view, untagged and tagged resources. AWS is a great resource, but many of the resources are untagged. CloudTrail, the hidden cost of AWS charges, they're all untagged. So I do my job perfect, where I do all the tags so that we can see what are untagged, the hidden cost across so many accounts, and what really is actual cost. And also by putting policies in place, in case somebody go holistic and start a couple of clusters, we can manage it well. The next slide will show you the wavefront graph we have put in picture. The slide is very busy. I have unmasked the numbers, accounts, names, and dollar figures, but I will walk you through the column. The first column in blue indicates the name of an accountable leader who has ownership of this group of accounts. He's accountable, he or she, to manage that account. It is his responsibility. The second column, which means a leader, finance has given us numbers that you can only spend so much this month, is budgeted. And the last four columns indicates we get data from the AWS, consolidate all the APIs from the billing, and show how much I spent today. If I keep on spending the same way, how much I will end up spending the whole month, and what percentage of amount till today I have spent. Pretty neat. It means you can look at a Slack, alerts, what is going on a single view. Next, can you see that yellow colors and red colors on the right, extreme right? Those indicates the alerting. If the numbers goes beyond 90%, for example, in the morning today, all of a sudden we saw October 3rd. What really happened? Our forecast is like showing red today itself. Guess what? We had spin off some vertical clusters and EMR clusters for our performance testing. So the alerts start shooting up. Hence, we know proactively take actions rather than have surprises. So that is a whole wavefront graph. Now, the next slide, as I mentioned, one account leader can have multiple accounts. How he or she will debug or a developer debug what is going on. This shows the details of the accounts the person owns and what percentage of money a particular account has been spending. For example, 94.94%, if they keep on spending the same way, end of month, that's how they'll spend. Now we talk about money account. Let's go to tagging. I need to figure out what all the resources are underutilized. I totally get it. Trusted advisor on the AWS gives the information. But for one account, what we're doing is consolidating all those accounts and showing to a leader, dude, that if you keep on spending, so much of resources are underutilized, so much resources are right utilized, so that the corrective action can be taken right away. Money saved is money earned. Do we all agree? We end up saving money here as well, right? And here it will show a tag level view as well. What is? Just took up, we enjoy sharing love. So the work we had done, we want to share with industry and want to share our love. This is a view we plan to open source in Grafana, whereby the same concept we want to take and divide aggregated view, provide information. All data is fake, by the way. They are all test accounts. They are not real accounts, all personal accounts. It will show you same view, whereby how much money forecasted, spent, everything, and one single shop of consolidation data it will show you. So in the last slide, what we are showing is before and after. Most of the patterns before and after, which makes sense. Single dashboard view, no kiosks, one-stop shop, underutilized resources. And also, if you look at the last column, we have open sourced some of the Terraform's work, what we had done in the last column. And also, we are spreading more love and we'll spend the open source of the Grafana as well. Thank you. Any questions? Source for all the dashboard cost usage report, but the budgeting is our own numbers, right? Our budget, so we are consolidating the data. All right, so I'm super excited to call our leader Sandeep on the podium, and he will take from here. Big round of applause.
That was a really nice session. Did you guys like the lightning talks approach? 15 minutes kept you awake? Yeah? By show of hands, I just want to make sure who was awake. First talk. First talk was the DDL change alerting. How many of you could relate to it? Okay. The second talk was EMR monitoring. Interesting. Third talk, we talked about anomaly detection and data quality. Wow. And the last talk, cost observability. In fact, it's very interesting when we think about observability, cost is the last thing that comes to mind. And it's the first thing that kills you when you actually are running in the cloud, especially in production with hundreds of analysts and data scientists using the platform. So on that, the next speaker, we have a very exciting next speaker. His name is Professor Shivnath Babu. Shivnath is the CTO and co-founder of Unravel Data Systems. How many of you have heard about Unravel Data? Okay, after this talk, our success metric is everyone will know about Unravel. But it's a really exciting talk. Shivnath is going to talk about how to focus or how to build reliable data pipelines using AI as well as data ops. Shivnath is, like I said, the co-founder of Unravel. He's also the adjunct professor at Duke. Very illustrious career, multiple awards, phenomenal number of papers. So very excited to have Shivnath. Thank you.
Thanks, Sandeep. Seems like I'm starting off. Need to share my screen. It refuses to show my. Yes. Yeah. Thanks, Sandeep. So it's a real pleasure to be here. And it's also a real pleasure to, again, thanks, Sandeep, for that great intro. It's a real pleasure to hear that. Yes. Thank you. That at least a decent crowd here has heard about Unravel. So without further ado, I'm going to kind of get started. It's, in fact, what I found very, very interesting. There are a bunch of talks that were given. The talk that Kilavar gave, the talk that Giri gave, they are very, very related to some of the things I'm actually going to be showing you today. And in a nutshell, the reason Unravel exists and what we want to achieve as a company is what you see on the screen here, right? I'm sure every one of you here and everyone who even stood up here and gave a talk in their teams, they're all either running, supporting, mission critical data related applications, sometimes called big data applications, sometimes called distributed applications. And these applications are here to kind of really make a difference, from a company like Intuit to e-commerce firms to healthcare firms. All of these applications are so important. And what has now changed, if you were to go back a few years, is they're all running on a collection of distributed systems, right? And if you know, and which is the reason why a bunch of talks were given, if one distributed system is pretty hard to manage, just imagine, right, how you can troubleshoot issues that could be happening across multiple distributed systems. So that everybody has a picture of what I'm talking about. right? Everybody, is probably familiar with their data sets, data sources. You're trying to drive insights with data. And here at Intuit, right? Seems like a lot of the infrastructure runs on AWS, where it might be using Kafka or Kinesis to ingest all of this data. It might then be storing it in a data lake, maybe S3, doing analysis on it, maybe Spark. I heard Vertica, right? There was reference to EMR clusters. Maybe these clusters are coming up and driving all sorts of applications from BI applications, right? I heard a lot about business owners, and maybe they are looking at dashboards, right? And along with this, there could be other systems like SageMaker for machine learning. There might be some real time. We heard about anomalies, right? Detecting anomalies has to be done in real time, right? So a lot of real time applications. And if you just look at this page here, right, I have not even shown what often are called NoSQL systems, right? Orchestration systems. Cyril was telling me that there's a lot of use of Tidal, which is a workflow scheduling engine. But if you start looking at this picture, you start to realize, right, if data didn't show up on the other side, right, or some anomaly happened, how are you even going to troubleshoot, the problems that happen, right? And this is what I heard some of the references that I think when Kilavar actually mentioned, hey, there's a data user who created the application, it failed. What happened? Where is it in this entire mess of systems? What went wrong, right? Where are the logs? Is it CloudWatch, Lambda, Splunk? Where is it? Right? It's pretty hard to find out. But what they're really asking for is, why did my app fail and how do I fix it? I don't even want to see those damn logs, right? To cost, right? And thanks, Giri, for setting it up very nicely, right? It's as Sandeep mentioned, everybody thinks going to the cloud is just so easy. I can run my hello world, I can get started, but then cost comes to kill you. And then so many choices, so many ways in which you can just burn money. And we as a small startup burn through $500,000 on Azure, just like that, running all over testing and whatnot. So cost really can quickly get out of control. Now on the data user side, and we also heard from the operation side, right, kind of what Kilavar and team were actually talking about. They don't look at individual apps, they look at the entire cluster, they look at things holistically, and there's all that element. And one thing which we are seeing a lot in the industry is, as this kind of migration happens to the cloud, there are even many other questions being asked, like which apps are a good fit for all the really nice features of the cloud, like elasticity, decoupled storage, right, all of that. And if I'm in the process of migration, I'm migrating one of my apps, do I even know that migration completed successfully? Lots of such questions come up. And this is the reason why answering these questions is hard, right? The root cause of a problem could be anywhere. It could be in your app. I had some data scientists came and wrote a SQL query and did a really bad join that read and joined 2 terabyte tables, right? To resources, resource allocation, network settings, on the cloud, noisy neighbors, you name it, lots of such problems happen. And what I'm here hopefully to show you in the next 20, 25 minutes is there is a very interesting opportunity to address these problems, just like what all the other speakers talked about, right? Bring all the data in one place and start applying algorithms to the monitoring data you can collect from these systems. And that can unleash and basically unlock a lot of value to the data users who want to use all of these systems, be productive, but don't want to get lost in all the complexities of managing these systems. There's an entire theme and an entire sort of industry that is emerging called AI Ops, right? It's combining all those operational level use cases, applying AI and ML on it to actually make things much better. And what I would like to do today is kind of give you a little bit more insight into how you can, at one hand, build a system, and I'll show you a few examples to help you understand. Whenever I hear the term AI, it all seems like it's all fake, right? What I want to show you is there is so much interesting things you can do with AI and ML, but what you have to first get over the hump is first putting together what is applying AI on all of this data monitoring data mean, right? As I showed you, there is a very complex stack, which is what you see on the left side. Many systems, you can look at the stack both vertically, like the application level, the infrastructure level, all of that, to horizontally, like I showed in the picture, right? Maybe data is being ingested from a Kafka, it is being processed in Spark, EMR or database clusters are coming up and going or auto scaling. The output goes into a Vertica and maybe serving a dashboard. So that is the element on the left side. And from these systems, you have to collect monitoring data. And bringing that is also a challenge, which, and again, Kilavar was referring to, right? You might have 200 accounts, AWS accounts where all of these clusters are running. Clusters might be auto scaling, right? How do you bring data from a Vertica or a Redshift and just like that, bring data from an EMR and Spark, right? All the resource managers. So a lot of interesting challenges, and data collection can be expensive as well. So you have to be adaptive, right? Otherwise, like, Splunk cost can kill you, right? Forget the cloud cost. And once you bring all of the data in one place, like there's a lot of different messy kinds of data, you start to have to correlate, relate things with each other, like, have some recommendation and insights extracted out of the data. So you have to do that so that at the end, the data users, right, or those business owners, instead of looking at all these messy systems and monitoring data, they are getting smart alerts. Alerts like what Giri showed, right? Hey, your cost are trending so rapidly that your quota will run out by the 10th of the month and not the end of the month, right? Smart alerts like that. 2 recommendations, and I'll give you some examples of how, some recommendations in delivered in time can help you both optimize cost, make things, systems faster, applications faster, right? And by no means I'm trying to, say that all of this is easy. There's significant amount of innovation needed in every level from, as I mentioned, collecting data, right? Clusters today are transient clusters. They're not like steadily running clusters, right? Cluster might come up and go, and maybe in a matter of minutes, right? How do you collect all the monitoring data from such a transient cluster, right? Or clusters might auto scale, right? Or the cluster may not even exist. It's a serverless environment. Like Kilavar mentioned Athena, right? So data collection to then data storage, right? You might have logs, you might have metrics, you might have query text, right? You might have SQL execution plans. How can you kind of store all of this data in a single system so that can even be analyzed in the first place, right? To then we get from the data and storage to the algorithms, extracting insights, right? And insights are always tricky because insights without context can actually lead you to drown in false positives, like those kind of things we saw in the anomaly detection talk, right? Insights with the right business context or the right domain knowledge about the system can be valuable. Something else could just be a false positive, right? And then finally, if you're taking actions, the power of AI is, as a user, you don't even have to tune the system. The system tunes itself, right? So it takes actions. And whenever something takes actions, you need it to be very predictable and reliable. Because the last thing you want is, hey, it took some action, but that was not exactly what my SLA needed. And it was a wrong action that ended up doing the wrong thing, right? So many interesting challenges. And I talked about a lot of these challenges. What I'll do in the rest of the talk is take 3 examples, right? And drill down to the extent that a 30-minute talk will enable me to. But that'll at least give you a good framework for how to think about solving these problems and to kind of show you that pretty interesting things can be done. Starting with application auto-tuning, right? What is the auto-tuning problem? The auto-tuning problem, I'll use one of them, which is how many of you here have run a Spark application? Well, quite a few have run a Spark application, right? And if you have run a Spark app, you know that there are hundreds of configuration parameters that can be set at a Spark app level. And nobody has a clue how to set all of these parameters. No, I didn't mean to disrespect anyone, but it's just becomes pretty challenging to understand. Driver codes, executor memory, SKU configuration, parallelism, you name it, lots of these configurations, right? And if it kind of abstract the problem, there is some sort of a performance surface as you change these knobs. Performance changes, and performance might be in terms of the end-to-end time of the application. It might be in terms of the cost of running the application. I'm just assuming here, let's say the time of running the application, right? There's some surface. If you see that surface, you want to be in that blue region. Blue is good because it's running time. I want my apps to finish quickly. How do you find that region? How do you find the right setting of knobs to get into that region, right? Now, wouldn't it be amazing if you had Like as a data user or a developer, you could say, here's my Spark query. My goal is to speed up the application, subject to resource I have. Some expert system go make it happen, right? And in a real-time sense, this is what it would look like. I want to make my application faster. So system thinks, does something, comes back and tells me, hey, I found a configuration to make your app 30% faster. Like, I go for lunch and I come back and it says, hey, like I found another configuration that can make it 60% faster, and so on, right? As a data user, I don't have to do anything. And in a real world, it might translate along the following lines, right? My Spark app, I ran it, boy, it failed, right? And it ran for 15 minutes, as you can see here, and it failed. And a lot of times Spark apps fail because they go out of memory, right? 15 minutes failed, right? And then I'm asking this AI-driven engine, like, that happened, can you help me? So a system does something, right? After some time, it comes back and tells me, actually, I was able to find a configuration to run that app successfully, right? From 15 minutes and failing, it went to 5 minutes and running, right? Maybe this is good enough for me. If this is an ad hoc application, I was able to run it. I get my results, I go on. A lot of the time, like we talked about today, these are pipelines that run where the app might have to run repeatedly, and I might be tuning the app, right? So then I would like the system to go and check again, right? And this time it checked and kind of said, hey, like, by the way, I was able to do one better. In fact, I found another configuration. It took more time, but it found another configuration that every time can run this app 4 times even faster in a minute, right? And this can continue with an AI-driven engine. It can then find a configuration that can run things faster and maybe even with less memory and memory efficient, right? And at some point, it will probably come and say, look, no, I can't improve it further, right? But the great thing about this is everything happened automatically from I ran my app, it failed. The system, the AI engine, recommendation engine, auto-tuned and gave me a configuration. And I can pick that configuration and then keep pushing that app in the pipeline and go on. This is the power of auto-tuning, right? And once again, the problem was that, look, there is some configuration parameter space, which in computer science, literature is often called the high dimensional space. There's a lot of configurations. And from that space, you want to find the region, the point, which actually optimizes performance. There are many algorithms that can be applied to this problem. This, from an AI terminology, this is called the reinforcement learning kind of approaches can be applied to this problem. But this problem itself is not new. It existed even before AI became a term. If you're in manufacturing, if you're in in the chemical industry, there are techniques called response surface methodology, which is because even they have to kind of solve a similar problem, right? We have done a bunch of research on this. Happy to share the slides. I don't have time to go into this in more detail, but what all of this literature often focused on is, give me an algorithm, which I'm referring to here as a probe algorithm, that based on the state and all the observations so far, can say what is the next best configuration that will take you closer to the goal, right? And that part is what has been heavily studied in the literature. But as with many things, right, that's actually one small piece of the larger puzzle. In addition to this algorithm, you need ways to run an experiment to kind of collect data, collect monitoring data, right? Combine it with a lot of historic data that might be available, combine all of that, and then give a recommendation. Because again, for a user, right, the key thing is they don't want to wait indefinitely. They might be just happy with a particular solution and they want to move on. It's a lot of interesting, both applications of existing work as well as opportunities to innovate here, right? To kind of get the interesting outcomes that I described. That's all I'll be able to kind of talk about that problem. Happy to discuss it more offline. The next one, this is the one that was of great interest based on Giri's talk, for example, right? When you look at a lot of the time, operations teams don't look at one single app or one single cluster. You look at everything holistically, right? Here is scary looking, pretty busy slide. But what I want to indicate here is just put all of those things you heard so far, which is if you're looking at an entire application and a cluster, right? There are so many dimensions to it. There is, of course, the resources, the nodes, the cores, the memory, all of that, right? There is the resource usage, resource utilization. There is all the applications that run. There are tenants that run these applications. There might be patterns of sometimes the cluster is busy, sometimes the cluster is not. A lot of these things, can we kind of take all of this and all of this data, analyze it to come up with a good way to overall cut down the cost, right? That is the challenge I'm talking about. And as you start to really kind of get deeper into this problem, you see there are ways in which you can find ways to optimize and cut down costs at many different levels. For instance, the application level, right? An app that SQL query with a good join might finish faster than if it had a poor join algorithm in there, right? Lots of inefficiencies often you see related to parallelism and containers and things like that at an app level. At a resource level, things like the node that you pick, right? How many scores, how much memory. Hey, if you have an app that was really CPU bound, probably you don't need all of those disk bandwidth and SSD sitting there, just a burning cost, right? From containers to if you have multi-tenancy and queue settings, a lot of ways in which you can cut down costs with data. The serverless system, Athena, that was talked about, right? That charges you entirely based on I/O. And if you have a query that's actually reading all the data stored as text, as opposed to reading only the columns, if the data were to stored as columnar, the cost could go down by a factor of 100, right? So lots of ways to optimize cost in the data dimension. And last but not the least, the tenant dimension, right? I don't know how many of you noticed, there was a slide that Kilavar showed which had expert advice in there. And the expert advice the system was giving was basically saying, look, hey, these are the times of the day when this cluster is very busy. Can you consider scheduling these non-SLA bound apps at a different time? So even from the business level, right, or tenant level and pipeline level, there might be ways to optimize cost. Right? And how do you do all of this? I'm going to show you some pretty interesting examples. Remember that Spark example I showed where for one app, we were trying to tune all of these configurations? Right? What if your cluster had 10,000 apps? Right? Nobody can go and tune each and every one of these apps, right? You have to look at things holistically. So instead of looking at the configuration at an individual app level, let's look at the configuration at the entire cluster level. The default sizes of containers, or I'll show you an example with the type of the node and whatnot. Here, I'm showing an example of a cluster. Think of it as an EMR cluster, which is running MapReduce or Spark with map and reduce kind of tasks. And you need to pick a good default size for the container. And I know you can't read it, but what it's actually saying is, hey, I ran an algorithm, I analyzed the entire workload, and you currently have your default container size set to 4 gigs. And I'm saying that you can actually run with 2 gigs container size default, and that by definition can cut down memory usage by a factor of 50%. Maybe you can use this less size node and save money. But there is another key thing it is saying. 97% of the workload on the cluster will run beautifully with 2 gigs. But there is a 3% that could be at risk, right? So this starts to bring out some pretty interesting dimensions of hey, when you're tuning, right? Sometimes there might be that 1%, 2% here, which is that bottleneck thing which probably prevents you from tuning things appropriately, right? Now, if an algorithm can automatically identify that, the beauty of the cloud is you can move those at-risk apps to their own cluster and still gain a lot of reduction in cost. So pretty interesting kind of things that can be done. Here's a real example based on these algorithms where a customer was able to cut down the resources needed at the entire application level by a factor of 2 while increasing the throughput of the cluster 2 times. So lots of interesting opportunities to cut down cost and improve performance using such algorithms which can look at workloads holistically. Here's an example of the a lot of the time people don't know, Amazon has 60, 70 instance types. Who knows which instance type to pick for the workload? Right? A very, very interesting and a hard problem, but that's a problem that is very amenable to algorithms where you can process all of this application usage and resource kind of data. What it's saying here is, hey, for this one pipeline that is being run, I was able to find a node or a node type, right, from a specific family that can cut down your cost and can even estimate the cost savings. Right? Again, interesting kind of algorithms can be applied here. So to summarize, right, the cost problem that Giri actually talked about, there are from visibility. Visibility is very, very important. Of course, observability, right? That's key. But there's also a lot of room if you're kind of connecting all of this data sources from resource usage and all of that to data and IO and data layouts, right? And with an ability to close the loop with automatic actions, because anytime the new cluster comes up, you can pick the best instance type for it, right? There's tremendous opportunities to save cost. That's pretty much all I think I will be able to talk about, if that clock is right, about the cluster optimization part. And moving on to the third problem, I just want to kind of illustrate, right? Largely, the industry is sort of moving towards the cloud. It's not like, I know at Intuit, you have a lot of your workloads already on the cloud. But by and large, many companies are probably at a stage where you guys might have been a year back, but they're moving workloads to the cloud. And that is another pretty interesting problem, like migrating, right? And don't think of migration as a one-time thing where I'm migrating from on-prem Cloudera cluster to Amazon EMR. Migration ends up being a constant exercise. You might lift and shift. And then you want to move from Cloudera on IaaS to EMR, right? To a platform. Or after running EMR, you might realize, oh, it's just too expensive. Why am I just paying all of that money to Amazon? Let me move all of that to Spark and Kubernetes. Right, so this migration, which is like I have a source system and I have a target system, and I want to migrate the workloads, actually it's a pretty interesting problem, amenable to a lot of these AI and ML techniques, where you need to understand your apps and your resource usage. Sometimes you need to forecast how those usage is actually growing, right? And in this world of lots of different options, certain apps can run really well in certain cluster configurations. How do you identify that? And basically connect all of that together to get a good mapping for your workloads so that you get the right price performance, ratios, right? Few quick examples before I wrap up here. With this movement to the cloud is all about how do I identify the patterns and the trends in my workload so I can make the right choices. This is just a quick example of how if you have a good forecasting technique, right? Then you can forecast when a particular resource will become the bottleneck. In a data center, adding more machines or addressing a resource bottleneck can take a lot of time. On the cloud, that's the beauty, right? You have all of these choices. So good forecasting can help you really keep your cost at a minimal level while migrating things pretty quickly. Another great example with the cloud is it's very, very easy to tier data. You can put some data in memory, you can put some data in the Glacier storage, right? Now S3 has all of these different kinds of tiering where you can, based on the access and the performance needs of your data, you can put it in the right cost bucket, if you will, right? So, and it's always the case that there will be a lot of cold data because somebody moved the data in, but it's not being used anymore, right? And this other thing, which is, it's invariably the case that most workloads will end up being some form of bursty. They might be, in this case, I'm just showing a heat map. It is a week cross 24 hours of the day kind of heat map. And Sunday is very hot. It so happens. Maybe there are huge weekly, weekend workloads that are running. If I knew that, I can really optimize my cluster for auto scaling or actually different kinds of sizes during the week versus not, right? Just building on that example, there are applications that might have a bursty behavior. You can use algorithms to identify them, and they may be good candidates to move to the cloud, right? Or extracting automatically, those tags. We heard sometimes users don't put the right tags in there, right? And there are opportunities to find and extract the right tags, do some auto tagging, or use customizable chargeback models to ensure that your costs are being optimized. All of that can lead to a pretty interesting suite of algorithms where you've observed all the monitoring data from a cluster or about an application, and then you can come up with algorithms to what is the cost or what is the best cluster configuration if you're lifting and shifting the workload, to what is the best cluster configuration if you have the choice of doing some performance to price trade-offs, like SLA needs to only be met 95% of the time, right? So there are pretty interesting choices there. And last but not the least, right? In a migration context, when you're going from a configuration where all the IO is happening locally to all the IO is happening over kind of remote storage, the way you tune might be very different. Here's an example of an app that on an on-premises cluster runs in 2 minutes, but when they migrate to the cloud, start taking 35 minutes, right? How do you get back and meet the SLA? pretty interesting choices like in there as well, where things can be addressed with data. So overall, again, hopefully that give you a quick sense of like how interesting algorithms apply to data can help solve many of the challenges we heard throughout like the session today, right? And I'm going to like stop with a quick plugin for Unravel. This is the kind of problems we work on. So if you're interested in trying this out, or one of the things that we have actually started doing more recently is we have a concept of office hours, right? Where people who have interesting challenges, you're working in the space, we are more than happy to like chat. There's a link we have put in here. Please sign up if you kind of want to just even discuss. Right? Seems like there's some interesting work that is happening here at Intuit, and we would love to kind of hear about it. So that's all. Thanks everyone, and happy to take questions.
Thank you very much for your talk. It's very useful, very interesting. So one of the questions that I have is you're showing about Spark tuning and you were showing some parameters. How are you deriving those parameters? Is it logs looking at Spark UI?
So the parameters are a property of Spark itself, right? Yeah. At a high level, there are properties related to parallelism, SQL, containers, like all of that. What we are deriving from logs and Spark UI and things like that are more of the metrics and measurements of how a particular setting of the parameters will impact performance. So it's sort of a combination of both, but what comes from the logs are performance measurements. Is that the question here?
Yeah, and then how, so like you were showing 4 measurements, right? The first time the job ran, it took so many minutes. Right. So you're learning all that continuously by looking at the logs?
Yes and no. Yes, because we are definitely measuring what is going on when you do run a Spark application. The no part is it's not like everything is being observed just based on that run. Right? There's tremendous amount of historic data. Spark execution, you can build performance models of Spark execution. So some sort of like, for lack of a better word, quick customization of existing models to kind of predict for that app and its behavior what's a good setting of the properties.
Right. Thank you.
Okay.
When you are saying that configuring the Spark right parameters, does it consider the cluster size, the instance size when it suggests those?
Absolutely, absolutely. And that's a mistake often people make, right? Like, the best tuning of a Spark app could be different based on, of course, your hardware and your node configuration, but even based on what else is running on the cluster. How much resources can this app even allocate, right? If it is the only app running on the cluster, maybe you won't have a lot of partitions that can all these tasks can run. But if not, right, you probably don't want to have that many because all of these tasks will just get stuck waiting to get containers allocated. So a lot of pretty interesting challenges there. And we have been working on this problem for a while. Happy to share more. Maybe you want to sign up for the office hours.
Thank you. When you were actually talking about, how you kind of finding out what's going on, tuning the cluster, finding out the parameters and all, we have also done the similar kind of stuff. We call it shadow testing. But good part that we had some kind of references from the on-prem systems, and we wanted to actually reach to that level where, especially from the SLA perspective, right? And then slowly when we reached there, we had to move to the cost, and then we had to meet the cost and so on and so forth. But the challenge which we found that as you said, we have hundreds of the instance types, and some are CPU bound, some are memory bound, and you have a different types of workload. Some of them workloads are actually CPU bound, some of them are memory bound, and they are somehow actually related into one particular segment. Right, and you cannot create multiple segment clusters just to support the CPU bound jobs versus memory bound jobs, right? So we had to somehow compromise, like as you said, 5% or 10% workload will be impacted with this solution, whatever we are providing. And you thought your answer was that can we move those 10% to somewhere else? So the question what I'm trying to understand, how we can actually tackle, because we know 70 to 80% problems we can easily tackle. But the main challenge is that 10 or 12%, because that is where the business impact comes into picture, because they may be actually very important jobs and which have more complexity and those kind of things and worries in terms of resource utilization. So how you tackle those, like instead of just shifting to other place, and then because out of those 10, 2 may be CPU bound, another 2% may be memory bound, and some are Spark jobs, some are MR jobs. You cannot keep on changing your cluster behaviors just because of they are 2% and all. So is there any trade-off in between? And
yeah, first and foremost, there is no silver bullet, right? But the ways to approach, like how we do it, I know you can't read this, right? But what we do is we analyze the entire workload, and we use the word decomposition, right? You can decompose the workload into those behaviors at an app level or at the entire workload level, the CPU profile, right? The shuffle and heavy and the network bound kind of profile, or it's like just reading so much data from storage, and that's where the bottleneck is. The problem that you're talking about can largely be tackled algorithmically, where you can generate these different profiles, and for that profile suggest a cluster type, and this can be used to optimize an existing workload, right? But what if there's a lot of ad hoc behavior, right? What companies, for instance, Netflix has done for that is they have an indirection layer on top where there are job clusters, workloads come over here, and then based on the profile, they get mapped to the right warm cluster pool, right? So that approach can also be taken. So it's really all about think about the problem holistically, and then based on the use case, applying the right algorithms. Yeah.
Talking about the query virtualization.
Genie, thank you. Yeah.
I have a follow-up question. Maybe you have already answered, because lots of things that Cloud mentioned and you answered. The way I'm going to come at it is, lots of companies are migrating to the cloud, right? So when they do cloud migration planning and stuff like that, a lot of this stuff can be useful.
Right.
But many companies who are actually on Cloudera, for an example, Cloudera distribution, they have a single cluster. That cluster is basically taking care of, scheduled workloads as well as ad hoc workloads.
Right.
When they migrate to the cloud, what recommendation you give them in terms of how many clusters? How do you help them decide what is the right configuration? What types of clusters?
Right.
How do you get there?
Yeah.
How do you make them get there?
Terrific question. So the short thing we tell them is use Unravel, but but the longer answer we give them is see, this is exactly the problem that Kilavar was mentioning too, right? Like on-prem, when people are running this, like they're forced to run large multi-tenant clusters, right? With all these things sort of mixed up. On the cloud, there's no reason to do that. You can start, and the word is decomposition, right? Like, hey, the Spark workloads are all CP bound. Let me pick instance type A versus all these things running Hive are just IO bound. A very, very simple example. So we have put in a lot of effort into creating algorithms that can look at that holistic thing and figure out how to slice and dice, right? Slice based on workload profiles, slice based on, sometimes it might simply be, hey, like this project versus that project. Like, they can move independently to the cloud and then figure out the right instances for them. But that's something which is pretty interesting problem, and something which is close to our heart. More than happy to dive into that offline. So
maybe I have just one
Please.
question, right? Because for you to come up with a recommendation, you have to know the workloads and types of things that are running
right.
on-prem, right? Without having run all those workloads, right, it can become tricky to come out with a recommendation. And that's what I was trying to gauge, right? How do you do that?
Right. So the essentially, like, again, source system, target system, right? Target system, the nice thing about the cloud is it's discretized, right? There are only certain number of node types, certain ways in which you have to do the cluster configuration. So again, more detail, but just to give the high level picture, you can benchmark each of those systems to have an understanding of what its profile is. So you can convert that problem. The best way I like to give this example is, if you think about you're building a language translator, and let's say you want to translate from English to Spanish, right? How do you do that? Like automatically, right? High level, what people do is they take 10,000 English documents, have them be translated into corresponding Spanish document, Now you have a training set on which you can actually build models. Think about the same thing being done where I have no types on-prem. I'm running a particular app there. I'm taking the same app and running it on a cloud cluster, right? And cloud is discretized, so there are only finite choices, right? Now I have representative data on which I can do a mapping, right? So many of these things can be, if you start really trying to attack it with the data and algorithm perspective, you can do a lot. And in many of these cases, the key thing is you don't have to be 100% accurate, because what we are sort of competing against is a human guess estimate, which can be totally wrong because they don't have the entire understanding and will take a long time. And the worst will have a large cost, right? So can we bootstrap this, get it started? And once you have had a particular choice and you've been on the cloud, this is a bad example where things completely went wrong. But usually you are 15% off, 20% off, and then you can optimize to get to the SLA, right? Those things are practical. Yes.
Thanks. On the training, you just said train data, right? How much is the percentage you recommend? What's the percentage you recommend to run an algorithm on a test data or a train data?
Again, there is no one size fits all, right? It's just a function of the use case. For certain use cases, you just get a lot of training data automatically on the cluster itself because the data being collected on the cluster is training data. In some of the examples I gave where you just don't have representative training data, which is like, I don't know what will happen if you change the SQL shuffle partitions for the Spark app. It's some ad hoc Spark app, right? Then you need to really collect more training data, but enough so that you can guide the configuration the right way, right? So long story short, is like, it's not like you need 90% training data or anything like that. It's all a function of the use case. Yeah.
Is there a way to detect unravel data, detect that? What is I keep tuning,
right.
Nothing is happening.
Right. I would generalize that question to say there is only so much you can do by tuning configuration parameters. If at the code level they are doing a horrible join, right? Then you have to get at that level. So the way we approach the problem is look at it holistically, right? The good news about configuration parameters is easy to change and rerun the app. But if you have to change something at the code level, maybe you have to rewrite, recompile. So it's always the approach is give that, so the way I would say that is like collect all the monitoring data and give the visibility to the user on where bottlenecks are, right? That should happen. The observability part that we kept talking about, right? That's important. And just don't throw logs and metrics at the user. Give them a good intuitive way so that they can relate their source to what is happening at runtime. That goes a long way. And on top of that, if you can give insights and recommendations, and even better if you can auto-tune, that's great. But instead of thinking the other way, where I always want to give a recommendation, right? We proceed in this more practical way. Bring all the data together, give good, visibility, and then enough insights, and wherever possible, give recommendations. Yeah.
We are 10 minutes over, so let's thank our speaker. That was terrific. Thank you.
Thank you. One last thing, we do have a book where we have summarized some of these kind of things. Alejandro is actually showing it. If you're interested, feel free to grab a free copy from the back. Thank you.
All right, guys. With this, we wind up a meetup for the day. And we'll sending the pictures on the meetup site. Please post your comments and see you next month. Thank you.
Thank you.
Thank you.
Thanks, Giri. Nice meeting you.
Really nice.